We shall commence this module by discussing about solving linear programming problems. Excel is a useful tool for solving linear programming problems. In this question, we will solve and analyze linear problem with Excel. Although the problem can be easily solved graphically or with the simplex method, we demonstrate how to use Excel so that you are able to tackle problems where the graphical method or the simplex method is impossible or not practical. In order to solve linear programming problems, we will use the solver tool found on Excel to solve problems. The capacity to solve linear programs is only available if you install the solver tool. Typically, this feature is not installed by default when Excel is first set up on your hard disk. To add this facility to your Tools menu, you need to carry out the following steps, but only once. First, select the menu option Tools, Add-ins. This will take few moments to load the necessary file. Second, from this dialog box presented, check the box for Solver add-in. Third, on clicking OK, you will then be able to access the Solver option from the new menu option Tools, Solver, which appear below the Solver. Please have a look at the scenarios. After studying this module, you shall be able to analyze linear problem with Excel, create spreadsheets in Excel, solve linear programming problems using Excel, understand the problems associated with solving linear problems with spreadsheet. Let us now discuss about creating a spreadsheet. This section explains how to set up a spreadsheet to solve linear programming problems. The best approach to entering the problem into Excel is first to list in a column the names of the objective function, decision variables and constraints. You can then enter some arbitrary starting values in the cells for the decision variables, usually 0. Excel will vary the values of the cells as it determines the optimal solutions. Having assigned the decision variables with some arbitrary starting values, you can then use these cell references explicitly in writing the formulae for the objective function and constraints, remembering to start each formula with equal to. Let's start by examining a Excel worksheet for the linear programming problem. The problem is to maximize P equals to 70x plus 120y subject to constraints x plus y less than equal to 35, x plus 3y less than equal to 75, 2x plus y less than equal to 60, x greater than equal to 0 and y greater than equal to 0. This worksheet is what we wish to produce for the linear programming as stated. The first step is to organize the spreadsheet to represent the model. We use separate cells to represent the decision variables, create a formula in the cell to represent the objective function, and create a formula in a cell for each constraint left hand side. Now we shall discuss about solving the linear problem in Excel. The worksheet utilizes Excel's Solver add-in to find the solution to the linear programming problem. Before we can create this worksheet, the Solver add-in must be installed within Excel. Once that is done, we can construct the worksheet shown above. The instructions shown below demonstrate how to load the Solver add-in for Excel 2007. Other versions of Excel may have a different sequence for steps. For help with the loading the Solver add-in in those versions, try searching in Excel's help utility with the term Solver. First, to load the Solver add-in, click on the Office button in the upper left corner of the Excel. Second, select the Excel options at the bottom of the menu that appears. This will open the Excel option box. From the left side, select Add-ins. If you see the Solver add-in listed, click on OK at the bottom of the box and skip to step 6. In this case, the Solver add-in is already loaded. Fifth, to add the Solver add-in, click in the Manage area and select Excel add-ins and press Go. In the add-ins box that appears, click in the box next to the solver add-in to put a check in the box. Click OK. The solver add-in is now ready to use. Sixth, now we can begin to make the worksheet that we will use to solve the linear programming problem. Enter the text shown in the individual cells. You will need to resize some of the columns. To do this, move the cursor to the top of the column you want to resize. Position the cursor over the border between the columns. The cursor will change to a double-headed arrow. If you hold down the left mouse button, you can move the cursor to resize the column like columns. Seventh, enter the coefficients of the objective function on a line labeled profit. Eighth, enter the coefficients of the constraints in the lines labeled capacity constraint, cutting constraint, and assembly and finishing constraint. Ninth, enter the right-hand sides for each constraints in the appropriate row in the column labeled RHS. 10th, in the row labeled solution values, enter an initial guess for the solution. These values can be just about any non-negative number. In this worksheet, we use the values xy equals to 0, 0 for simplicity. The cells you place the guesses in, B9 and C9, are called the changing cells. These values are used to evaluate the objective function and left-hand side of the constraints. Then place the appropriate inequalities in each constraints row. 12th, in cell D4, we want to calculate the value of the objective at the solution values in cells B9 and C9. This cell is called the target cell. Click your mouse in the target cell. In the formula area, type sum product bracket opens $B $9 colon $C $9 comma B4 colon C4 brackets closed. Press enter on the keyboard. The sum product function multiplies corresponding cells and adds the result. In this case, the solution values in B9 and C9 are multiplied times the objective function coefficients in B4 and C4. The sum of these products is placed in the target cell. 13th, the dollar signs used in step 13 are called the absolute references. Absolute references are useful when fills are used to create entries in cells. Click on cell D4 again. Notice the darker box in the lower right hand corner of the cell. This box is called the fill handle. Move your cursor over this box and you will see that it changes to a black cross. Left mouse click and hold the mouse button down while dragging the cursor to cell D7. Release the mouse button. This fills the cells D5 through D7 with entries based on the formula in D4. If we click on cells D4 through D7 and examine the formula bar, we see a pattern. In each of the cells, one factor in the product always comes from the solution values in cells B9 and C9. The other factor in the product comes from cells in B and C column on the same line. Cells that are fixed in a certain locations are called absolute references and utilize the dollar sign. Cells that are located with respect to another cell are called relative references. When the cells are entered using a fill, relative references are filled with values according to their location. For this worksheet, the second part of each product comes from the cells immediately to the left and on the same row. The other part of the product is fixed by absolute references in B9 and C9. Now, we will utilize a fill to put the entries under the slack label. The slack is the difference between the right hand side and the left hand side of a constraint. Left mouse click on cell G5. In the formula bar, type F5 minus D5. Now press enter to calculate the slack for the capacity constraint. This value is the difference between the left hand side and the right hand side of the capacity constraint. Now left click the mouse in cell G5 again. Use the fill handle to fill the cells in G6 and G7. To test whether the cell entries are correct, let's try some different values by changing the values in cell B9 and C9. Change both of these values to 1 and observe the values in the target cell D4. The left-hand side values of the constraint in cells D5 through D7 and slack in G5 through G7, the values on those cells should match. If any of the cells do not show the correct values, examine the contents of that cell and make changes to correct the entry or formula in the cell. Once the worksheet is calculating the proper values when the changing cells are varied, we can use the solver add-in to solve the linear programming problems. Now, click on Data tab along the top of the Excel window. In the Analysis panel, click in the Solver button. The Solver tool will open. Before we can enter any values into the Solver parameters box, we need to set some options. Click on the Options button. Use the cursor to check the boxes Assume Linear Model and Assume Non-Negative. Click OK to return to the Solver parameters box. Make sure the cursor is positioned in the box next to the Set Target cell. Now click your mouse in the cell D4. The absolute reference $D$4 will be placed in the box. This cell contains the value of the objective function evaluated at the solution values. Make sure max is checked since we are maximizing the objective function. Position the cursor in the box by changing cells. Click and hold the left mouse button in cell B9. Drag the cursor to cell C9. This selects the two cells containing the guess for the solution values. The absolute references for the cells are placed into the changing cells box. To enter the constraints into the solver, click on the Add button under the Subject to Constraints heading. The Add Constraint box will open and allow you to enter the left-hand side inequality and the right hand of the first constraint. Position the cursor in the box under Cell Reference. Click on cell containing the left-hand side of the capacity constraint D5. Next, position the cursor in the box under Constraints. Click on the cell containing the right-hand side of the capacity constraint, that is F5. Click the Add button. Repeat step 24 for the other two constraints and the corresponding cells for the left and right-hand sides. It is not necessary to enter the non-negativity constraints. Once the constraints have been entered, click on OK button in the Add Constraints box. You will return to the Solver parameter box. At this point, the linear programming problem has been entered into the solver and now we are ready for Excel to solve it. Click on the Solve button. The values in the cells are changed to correspond to the solution of the linear programming problem. According to Excel, the solution is xy equals to 1520. Notice that in the first two constraints, the left and the right hand sides appear to be equal, but the slack is not equal to 0 as it should. This is a rounding issue due to the nature of the algorithm used to solve the problem and is nothing to be concerned about. If we were to start with a different initial guess like 0, 0, the slack for each of the first two constraints would be 0. Highlight the answer and sensitivity reports and click on the OK button. Two new sheets will be created in your Excel workspace, Answer Report and Sensitivity Report. You can click on the tab for either of these reports at the bottom of the Excel window to view them. Next, we shall understand loose ends or problems associated with the spreadsheet. Some of the problems associated with solving linear problems with spreadsheet are: first, infeasible problems. If your feasible set is empty, then Excel will tell you. After you ask Excel to find a solution, the solver result box appears with the statement that solver could not find a feasible solution. Provided that there are no mistakes, this means that the problem is not feasible. There is no solution to find and there is nothing else to do. Second, unbounded problems. If your problem is unbounded, then Excel will tell you The solver results box appears with the statement that the set target cell values do not converge. The spreadsheet then provides you with a finite guess for all the variables, but the guess will have the property that you can increase at least one of the variables without bound, maintain feasibility by varying only the variables that have positive values, and increase the objective function without bound. Third, mysterious failures. Almost certainly something will go wrong at some point. Maybe it is the hardware. Maybe it is the software. Probably you made an incorrect assumption about how the program interprets the data you give it, or you just typed a formula or cell address incorrectly. Identifying the problem is frustrating and often time consuming. If you obtain a numerical answer, then I urge you to examine it to see whether it looks sensible. It could be the answer to the wrong problem. If solver does not work, then go over the data and formulas slowly and carefully. Usually you will find a mistake. Fourth, sensitivity analysis. At this point, you can generate a report on the sensitivity of your solution, but you cannot interpret this report. Sensitivity analysis is a major topic of the course. I will teach you what this report means soon. Now, we will summarize what we have discussed in this module. In this module, we have learnt that the best approach to entering the problem into Excel is to first list in a column the names of the objective function, decision variables, and constraints. We learned how to convert linear programming problems into spreadsheets for use in Excel. Some of the problems associated with solving linear programming problems with spreadsheets are invisible problems, unbounded problems, mysterious failures, sensitivity analysis.